In the first video, we studied working elements of robots. In this video, we will study about designing a robot. What does it mean to design a robot? Designing means choosing aim of robot, choosing appropriate sensor, and choosing appropriate battery, choosing output devices other than actuators, choosing and programming appropriate controller, choosing right body for our robot. These are the 6 steps that we do during designing a robot, and they should be done in the same order. Choosing aim of a robot. In this step, we decide what our robot is going to do. Like, will it be line follower, maze solver, object avoiding robot, self-balancing, and there are many more aims for our robots. Choosing appropriate sensor. In this step, we decide what sensor will be best for our robot, such it can perform accordingly. Let's take an example. For a maze solver, you can use IR sensor, ultrasonic sensor, also push button type sensor. So we choose one of them which is best for our robot. We will be considering input devices as sensors while making robots in the future. Choosing appropriate actuators and battery. Actuators basically means everything that can show motion in response to an electrical signal. Most common example is motor. Appropriate means right type of motor or actuators. For example, brushless DC is used in drones, stepper for a self-balancing robot, or a simple DC for any other task. Battery of robot is also chosen according to our actuators because they feed most of its power or energy. Choosing output devices other than actuators. We should decide whether we need output devices other than actuators and choose them in this step. For example, do we need an LCD, do we need a speaker, do we need a flashlight, etc. There are many more output devices that are not actuators. Choosing and programming controller. We choose controller based on our sensor and processing power and output devices that are not actuators. Basically, actuators don't need much processing power. That's why our choosing of controllers doesn't depend on actuators. You need different controllers for different need. For example, if you have a camera as a sensor, it needs more processing power. So it would be wise to choose a DSP or a processor based development board, i.e. controller. Programming languages used for robots. Programming of a robots are done mainly in 3 languages. Number 1, C. Basically, all controllers support C. That is the main reason why we use C in programming. For example, you know Arduino, it is programmed in C. You have 8051, or if you are trying to program any Atmel devices, any Atmel controllers using their Atmel Studio, then you will be programming them using C also. Number 2, MATLAB, because its ability to solve control system problem easily. Mostly all industrial robots are designed using MATLAB. I said mostly because not all of them, most of them. Number 3, Python, because of its ease of learning and use, and also because of its wide applicability. Types of programming approach. Programming of a controller, it is done in 3 ways. This is not their official definition. This is how I define them. Number 1, truth table approach. In this approach, we design our programming structure very similar which is very similar to how we design our digital logic circuits. Example of robots that can be designed using first approach are simple line follower. Second approach is control system approach, and this is used when we are designing robots that are using variable sensors. What I mean by variable sensors, that means sensors or actuators have a range that they provide output or that they get input in. Example of such robots is a self-balancing robot. What I mean by range is that gyro sensor, it provides a range of angles that it is currently in, or in case of motor, then it requires a variable speed, that speed would be plus something या minus something. And the third approach is metric calculation approach. Metric calculation approach includes both of first approaches, plus there is much more in this approach. We will discuss in after we have completed first two approaches in robots. And what type of robots are designed using this approach? Basically human robots or robots that are more intelligent, that are more reactive to our responses. 6. Designing right body for our robot. Robotic body have a few key aspects to it. As long as you follow them, it doesn't matter how and what is your robot body is made of. These are stability. Your robot should be stable, well balanced and durable. Protects controller and sensors from physical damages. Have separate slots for different parts. ऐसा नहीं होना चाहिए कि तुम्हारा कि बैटरी हवा में झूल रही है या फिर माइक्रो कंट्रोलर के लिए जगह नहीं है, इस टाइप का नहीं होना चाहिए. तुम्हारे हर पार्ट्स के लिए एक डिफरेंट स्लॉट्स होना चाहिए और वो पार्ट्स उसी में होने चाहिए. एंड डोंट हैव एनी ओपन वायर्स. तुम्हारी कोई ओपन वायर्स भी नहीं होनी चाहिए, क्योंकि अगर तुम किसी कंपटीशन में पार्टिसिपेट कर रहे हो या हॉबी के लिए बना रहे हो, या फिर फॉर एग्जांपल तुमने ड्रोन बनाया और अगर कोई वायर हैंगिंग कर रही है या झूल रही है तो वो डैमेज कर सकती है रोबोट को. So for more such videos, like, share and subscribe. From next video we will be start making videos of robots, their procedure, और उसमें मैं दिखाऊंगा अभी कि इन 6 स्टेप्स को कैसे फॉलो करा जाता है, कैसे मैंने किया. थैंक यू.